Okay. Today in the earlier morning session, I saw a few people asking the doubt what exactly statistics is. So I thought I would add this slide, the definition of statistics. Like if you are studying the subject, you would want to know what the subject actually means, right? So I was thinking if I could give you a few examples, few definitions on the subject statistics itself. Statistics has been defined differently by different authors from time to time. The reason for a variety of definitions are primarily two. The first is in modern times, the field of utility of statistics has widened considerably. In earlier times, in ancient times, statistics was only limited to state affairs. Like the king or the ruler would just gather the information of the population in his country, be it about property or wealth, to have the idea of the manpower in his country. But whereas now statistics is used in all sort of affairs, all sort of field, be it planning, mathematics or economics or finance or business. And second reason for statistics evolving is, first, it can be either be defined as statistical data, that is numerical data, that is facts and numbers. Secondly, it is defined on assumptions and principles and techniques used to collect data. For now, we use this latest definition, which is statistics may be defined as the science of collection, presentation, analysis, and the interpretation of numerical data, which was defined by Quartiles and Codwin. Am I making sense?
Yes.
Yeah, so that's it. There's few more definitions in the page. That is statistics as numerical data defined by Webster was, statistics are classified facts representing the condition of people in a state. Suppose the height of a person, the weight of a person, all these are statistical numerical data. But when it comes to statistics methods, we use definitions such as estimations and probabilities. This is how we differentiate. This is also how we differentiate our statistics, that is inferential data and descriptive data. Descriptive data mostly covers the numerical facts and conditions, whereas inferential data mostly covers the presentation and analysis and probabilities of estimation of data. Now we proceed to the types of data. That is, we have 4 types of data. If we go we have 4 types of data. First categorical data is divided into 2 types of data, that is nominal and ordinal. Categorical data is basically categorical data is something which we cannot count, which we cannot measure. It's basically feature or maybe some maybe some property of a particular item or person. Like the gender of a person, it is a feature of a person, right? It is not, you cannot measure them in numbers. It is male, female or transgender. There are only 3 options available for the gender of data of a person. Again, categorical data is divided into 2 parts, that is nominal or unordered, which these sets of data do not have a natural ordering. Like we cannot compare these data with one another. Suppose I have a smartphone of black color and my friend has a smartphone of pink color, but we cannot compare such data. The another thing is that we cannot compare the data of male and female, the gender of a person, where we cannot differentiate between, we cannot, I mistaked here, we cannot compare the features a male person has different features and a female person will have different features. We cannot compare the features of such data. These are called nominal data type, which do not possess a natural ordering. Ordinal or ordered data sets are natural ordering. Like suppose the size of a clothing brand, small, medium, large, XL. It goes orderly. First small comes, then medium, then large, then XL. Same way, the height of a person, it goes orderly. Short, medium, tall. Weight of a person, thin to fat, huge, that way. Is it clear?
Yes, Rashmi, you can proceed. If at any point some doubts come, we will ask. No issues. You can proceed. Yeah, you're on.
Okay, thank you so much. Then we come to the next types of data, that is quantitative types of data. They are basically these types of data can be counted or calculated using numbers. We did categorical data, which could not be counted or measured. These were features or property of a data or a data set. But here, quantitative data can be calculated using numbers or can be counted. Either the data set provided can be finite, suppose the number of students in a class, or the number of planets in the universe. But also their data set provided can have infinite number of data, like the number of stars in galaxy, or maybe the number of hair in a person's body. The quantitative data are again divided into two parts, that is discrete and continuous. Discrete is integer or a whole number. It is exact. It cannot have any rational numbers or any point numbers. For example, the number of bones in a human body. We have 260 bones in our body, which is exact. It is not half, or it is not like, it is not in point. Same goes the number of teeth in our mouth, or the number of eyes, the number of ears in a human body. These are discrete data sets. Whereas continuous data sets are fractional numbers. They are continuous values. It can be fractional point numbers like height or weight or temperature or length. Okay. Is it clear? Data types. There are 4 data types. First, we have nominal and unordered, ordinal or ordered, and then discrete and continuous. Data types are briefly classified into 2 types. First is qualitative or quantitative. Okay. Then we have is averages or measures of central tendency. According to Professor Bowley, averages are statistical constants which enable us to comprehend in a single effort the significance of the whole data set. Central tendency is a single value in a data set which is the representative of the entire distribution. Just a single value can give us the idea of the entire distribution, or it can give us it can tell us about the concentration in the center part of the distribution. It helps us to calculate an accurate description of the entire data. Central tendency is based on all the observations, and it is suitable for further a value of central tendency is suitable for further mathematical treatment, that by which means that we can calculate the averages and size of a number of series using this value. There are 5 measures of central tendency, but the upgrade has but in our upgrade they have done only 3 kinds. So I've just mentioned the 3 central tendency done in our upgrade. that is mean, arithmetic mean, and mode. Geometric mean and harmonic mean hasn't been done in our modules, so I did not actually add them. Is it fine?
Yes, Resh.
I actually did not add geometric mean and harmonic mean because it will be confusing for the people who do not know about it or who haven't gone through the modules. We can do it later part.
Yes, we can discuss it later once everyone has the clear understanding of the topics and basics.
Okay. So the mean, first is the mean. Mean is the is defined as the sum of observations divided by the number of observations. It is the simplest. It is the easiest central tendency. It is the easiest measure central tendency. And in case of group distribution, where we have frequency, sometimes it's not only the variable and the number of observation, but sometimes the question can also come with frequency. Then we use this formula where mean equals to the summation of product of frequency and the variable divided by the number of frequency. Number of observations. For example, we have a data set 1, 4, 2, 6, 7, 4, 6, 2 of random numbers, and we need to find the mean. We first will find the sum of numbers in the set, that is 1 plus 4 plus 2 plus 6 plus 7 plus 6 plus 2, which is 32. And here we count the number of observation. The number of observation here is 8. So the mean here is just 32 divided by 8, which is 4. So the mean of this data set, this particular data set of random numbers, is 4. Second example I've added is where the frequency is given. Find the arithmetic mean of the following frequency distribution. I have added all easy examples for everyone to understand, for beginners to understand it properly, and then we can, like, when we go further in the applied statistics field, we can go with the tougher examples. So first I made it into a tabular form so that's easy for everyone to understand. First row we have the x, that is the variable, and in the second row we have the frequency, that is f, and in the third row we have the multiplication of frequency and the variable. So we can see 1 into 5 is 5, 2 into 9 is 18, 3 into 12 is 36, 4 into 17 is 68, 5 into 14 is 70, 6 into 10 is 60, 7 into 9 is 42, and total. And then we found out the total of frequency, that is 73, and total of product of frequency and variable. Then the mean here is simply simple division of the sum of the product of frequency and variable, that is 299, divided by 73, that is the total number of frequencies, which is 4.09. Is it clear? Is there any confusion?
Okay, I would like to add one point here. So you may be wondering when we will try to use things like this. So what is the difference between this mean when we have a distribution or when we are given frequency and all? So you can think like, suppose I'm having a product line where I am like concerned about the weight of I'm trying to make some product and I need to be concerned about the weight. So then suppose I tell like finally output I got 10 items with weight 10 kg. The 20 items with weight 10.1 kg, 30 items with weight 10.2 kg, things like that. And then if I want to find out the mean weight of the process or the outcome, then I will use for the second approach that Rashmi told now. I will like a 10 into 10 plus 20 into 10.1 plus 30 into 10.3 divided by 10 plus 20 plus 30. So that will be like a practical application of the frequency based approach. When coming to the other thing, Suppose I have the observation of the height of all the people in a class. 180 centimeter, 182 centimeter, 150 centimeter, 180 centimeter, like that. I have 30 people. Each person will be having a different height. Like then I'll be adding that everything, and then I'll be dividing it by total number of students in the class. So that will be like a practical application for the first case. So I hope that example will like make more. You will be able to more think about that, right? Rather than directly going to numbers. So I think with the number example that Rashmi told and the practical example that I told, this concept will be very clear. I think if okay, Rashmi can proceed then.
Okay, thank you. That was helpful. Okay, this is another type of question where we need to find the mean again. Here the marks is given. The marks of the students are given in class intervals, and the frequency here are number of students which have the number of students who acquired marks in that class interval, in that range, we can say. So first class interval we have 0 to 10, then we have 10 to 20, then we have 20 to 30, 30 to 40, and 40 to 50. Then again we have 50 to 60. These are the class intervals of marks obtained by the students of a class. So for our variable x, here we need to find the midpoint of the class. To find the variable x of this data distribution, we need to find the midpoint of the class, which is 0 plus 10, the lower limit plus the upper limit divided by 2. Lower limit here of the first class is 0 and the upper limit of the first class is 10. So we add 10 plus 0 is 10 divided by 2, which is 5. Then we do the same for the rest of the classes. 10 plus 20 by 2, 15. 20 plus 30, which is 50 divided by 2, which gives us 25. Then 30 plus 40 divided by 2, which is 35. 40 plus 50 divided by 2 equals to 45. And 50 plus 60 divided by 2 equals to 55. So this is the way we find out the x, the variable x for the distribution data set. That is the midpoint. Basically, x here is the midpoint of the class interval. Then we multiply the frequency and the variable. We find out the total sum, that is 2800, and the number of students here is 100, which is our number of total number of frequency. Then we divide 2800 by 100, which is 28, and it is our mean. Clear?
Yes.
Okay, thank you. Now we come to the second central tendency, that is the median.
How you got 2008 in previous example?
Pardon?
Previous example, how you got 2800?
I added these frequency, like the frequency here for the first data set for the first class interval is 12, and the midpoint for the first class interval is 5. So I multiplied this to 12 into 5, which is 60, and I did same for the rest. 18 into 15, 27 into 25, 20 into 35, 7 into 45, and 6 into 55. And then I calculated the product of f and x, that is frequency and variable. And then I simply added all of the products together. That is how I obtained 2800. Fine?
Yes, here you have calculated, right? 0,
Yes.
10. What if there is number like 0, 10, 20? Do we need to calculate average for that? Because you have divided 0 plus 10 by 2.
No, this is not the, you can tell that this is the average, but this is the midpoint to find the x. When data set which with class interval is given. Since the class interval consists of two numbers, right? Lower limit and upper limit. The total number of data here is 2. That is the lower limit and the upper limit. Hence, we divided by 2. Okay.
Thank you. Okay.
You can update. We need not bother about chat window that we.
Okay, okay. Thank you. Okay, so
We have done with mean, right? So we're moving to the median.
yeah, moving to the median. Median of a distribution is the value of the variable which divides it into two equal parts, which divides the whole data set into two equal parts. A median is a positional average. It is a positional average because the number of observations preceding and succeeding the median are equal. So, since in simpler words, we can say that median is the middlemost value of the observation. And a very important point before calculating median is that our data should be sorted either in ascending order or descending order. It doesn't matter, but it should be sorted. If it isn't sorted, then the median which we will be calculating might not be the accurate median of the data set. For even number of observation, we can find out median by adding the n by 2th observation and n plus 2 by 2th observation and dividing the whole observation by 2. And for odd number of observation, we can find median by n plus 1 divided by 2th observation. Here n is the total number of observations. Here I have given you an example for better understanding. First, we have X, a data set X, where we have a sorted values of data 1, 2, 3, 5, 6, 8, 9, and 10. The number of observations here is 8, which is even. So we put the formula 8 by 2 plus 8 by 2 by 2. Then we divide the whole thing by 2. Here, for even number, we need to make one thing. We need to keep one thing in mind, that median is the averages of the two middlemost number. Since here the two middlemost numbers 4th and 5th, right? For 8 number of observations, the 4th and the 5th observation are in the middle. And here the 4th observation is 5 and the 5th observation is 6. So we add 5 and 6 and then divide by 2, we get 5.2. The median here is 5.2. For even observation of numbers, the median is the averages of two middlemost number. Is it clear? Or is it confusing?
Okay. 8 is okay. Total number, right? 1, 2, 3, 5, 6, 8, 9, 10. So total.
In simple terms, it will be like this. If you have 10 and it will be like in the middle. What will be in the middle? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The middle will be like 5 and 6, right? So you have to
Your voice is echoing.
Okay. So I think now clear. So basically, suppose you are having 10 entries. So it will be numbered from assume index from 1 to 10. So then what will happen is you need to find out the middle value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Middle one will be 5th and 6th one. So you are supposed to find the average increase at the 5th and 6th. So that is what this n by 2 plus 2 by 2. That basically means that you are supposed to find the left, find the middle point, then find 1 and 3 to the left, 1 and 3 to the right. Take those 2 points and find the average.
Yes, exactly. Shall I proceed?
Reshmi, could you please cover one topic if you feel like, means when to use mean and when to use median?
When to use mean and when to use median. We use mean when we need to find the average of a data set, and median when we need to find the
I will answer that. So basically, we are supposed to find.
Anand, your voice is still echoing.
Suppose I
Reshmi,
have a data, whether some all the data is like more or less following the same range. In that condition, I can use the mean. But suppose I have a data where I have like I am counting the height of people. And suppose there is one person who is too short, like maybe let's say 100 centimeters across, and everyone else is falling around 160 centimeter that range. Then the 100 centimeter person will be actually biasing my decision if I take the mean as a measure of central tendency. So in situations like that, I will go with the median approach. I will try to arrange everything, sort everything, and then take the middle value. I hope that example makes it.
Arun, your voice is echoing. I don't know. Yes, it is. It is for everyone. I don't know.
Hello Siri, your voice is also echoing. Actually, the thing is that one person when speaking, rest all can be mute. Like
Yes,
Rashmi is
please.
now,
Please go mute.
yeah, now one can speak. I'm muting.
is the doubt clear when to use mean and median?
Actually, Arun's voice was not clear. Reshmi, could you please go on mute and Arun, please explain again.
Yeah, sure.
Thank you.
Okay, how about now? I hope there is no echo now.
Perfect. Thank you so much.
Suppose I am having data like 100, 161, 160, 162, as I have turned the chat window for my height of the people in my class. So basically, as you can see, if I try to find the mean here, the guy with the shortest length, 100, will be actually biasing my decision of mean by bringing it much further down. But whereas a much more better central tendency in this case will be median, which will give me 160 plus 161 by 2, 160.5, because that will be like more suitable as a measure of central tendency in this case. So for situations like this, we will go ahead with median. Now suppose almost all my data is within a range, we will use this mean. Now where is the distinction point between where we will take mean and median? When we go for interquartile range, that point we will see again. We will compare the interquartile range with the range, and then we will see whether we should go for median and mode, median or mean. And in some cases, taking both will be okay. And in some cases, taking one over the other will have certain advantages. I hope it is clear. So you can proceed, Rishmi.
Thank you, Arun. So median is clear, right? The third example. So the third example here, we do not have a sorted data set. So first thing we do is we sort the data set and then we find the median, same as the first one. We first find the two middlemost number, two middlemost observation, that is the fourth and the fifth observation, which is 66 and 67. Then we find the average of 66 and 67, which is 66.5. So the median of this data set would be 66.5. Okay. Now we come to the third central tendency, which is mode. Mode is the most frequently occurring value in a set. In other words, mode is the value which is predominant in the series. Number an observation which is occurring frequently, or let's say the maximum number of times. Here the example, the mode of data set. Here it is 2, since 2 is occurring thrice in the data set. We can see that 2 is occurring thrice in the data set. And in the second data set, we have 11 and 56 as the mode. Mode can be multiple, since there can be 2 or 3 number of observation which can be occurring at the same number of times. I have added this one more topic, mode for continuous frequency distribution. It is easy, but it is not included in the upgrade module. I've just given an example of how to solve this using this formula. Model class, when we have the frequency given, like suppose you have given the class interval, let's say the class interval of marks again. The class interval here 0 to 10, 10 to 20, 20 to 30. When it is when a class interval is given, we use the formula. We use this formula, this mode for continuous frequency distribution. Here L, this is lower L, which is the lower limit of the model class. Model class here is the class interval with the maximum number of frequency. Maximum number of frequency, which means that class is occurring maximum number of time. The maximum number of frequency means that class is occurring maximum number of time in a data set. So here the maximum frequency is 28. So the model class here is 40 to 50. So in the formula, L is the lower limit of the model class. H is the magnitude. Magnitude as in the lower class minus upper class minus the lower class. I'm so sorry. Upper limit minus lower limit of a class interval. H is the magnitude. H equals to upper limit minus lower limit. And F1 is the frequency of model class, and F0 is the frequency of the class preceding the model class, and F2 is the frequency of class succeeding the model class. Here 28 is the model class here, model frequency here, which means that 40 to 50 is our model class. So here L will be 40 and F1 will be 28, F0 will be 12 and F2 will be 20 and H will be 10. 50 minus 40 is 10. Here the maximum frequency is 28, hence the model class is 40 to 50 L is 40 and H is 10. So we put the formula and we find the mode, which is 46.667. Is it clear? Is the example confusing? Okay. Now we come to measures of position. Values which divide the series into equal parts. It is called partition values. I forgot to mention here. Values which divide the series into equal parts are known as partition values, which comes under measure of position. We have three different kind of partition values. One is first is quartiles, second is deciles, and the third is percentiles. Quartiles, there are three quartiles. One is the first or the lower quartile, that is Q1. The second is the second quartile, also known as the median, and the third is the third quartile or the upper quartile, that is Q3. First quartile comes at 25% of the data. It has 25% of data before it and 75% of the data after it. And the second data, which is our median, comes at 50%, which is at the right middle point of our observations. Then our upper quartile, that is Q3, it comes at 75% of data, which means that it has 75% of data before it and 25% of data after it. Basically, quartile 1, that is the lower quartile, is the midpoint of the first half of the median, and Q3, the third quartile, is the midpoint of the second half of the median. Then we have Dexiles. It is the points which divide the series into 10 equal parts. There will be 9 points and it will be dividing the series into 10 equal parts. And the third is our percentile. Percentiles are 99 points which divide the data group into 100 equal parts. We can use this formula to find the location of a percentile, that is n plus 1 multiplied by p divided by 100. P here is the value of desired percentile. Suppose I want to find the location of 28th percentile, and the total number of observation here is 40. So I can use this formula simply by putting 40 plus 1, that is 41, multiplied by 28 divided by 100. Which is 0.28. So 0.28 into 41 will give us 11.48. So the 28th percentile of our data, of a particular data set, might having 40 number of observation will be 11.48. Is it clear? Measures of position. I couldn't find a proper. Yes, n is the number of elements in the series.
You can go to an example, Disney. That will be more clear.
Next is interquartile range. I have interquartile range is basically the third quartile minus the first quartile. I have given example for this. Find the interquartile range of this data set. Here the mode is somewhere in the red line. The mode is not required, so we did not calculate that. The first half, the first half of the median. Sorry, the median is not required here, so reason why we did not calculate. So the first half of the median, we take it to find the lower quartile, that is Q1, which is 24, and then we take the second half of the median to find the upper quartile, which is Q3, and then we find the interquartile range, which is Q3 minus Q1, that is 4. Okay, that is it. Okay. Can we do measures of dispersion tomorrow? I don't know, it's just not there anymore. I guess I forgot to save. I'm so sorry, I did, but then there was this power shortage and it just went off.
Rashmi, I think you can just tell an example of how you compute quartiles, percentile. Yeah, with that we can close today's session.
Just do that.
So just put some random numbers and tell them how you can find that.
Yeah. Suppose we have n equals to 45, which is the total number of observations. Okay, and I am asked to find the 28th percentile of this observation. So I can use the formula location of a percentile which is equals to n plus 1, that is 45 plus 1 into p divided by 100. Here 45 plus 1 will give us 46 into p divided by 100 will give us 0.288, which will give us 12.88. So this will be the 28th percentile of the observation, which has total number of observation as 45. Is it clear? Percentile, how to find the location of a percentile? Okay. Vision is percentile 28%. No question. Anything you weren't clear about in the slides or the examples?
Pankaj here. I have one question.
Yeah.
Yeah, so what I found is while calculating the median, right? If the number n is even, then
Yes.
it is giving the actual value. But when n is odd, it is giving the position, not the value. So why is that behavior?
No. When n is odd, it is still giving the value. Fourth observation, which is our 22. It is giving
But
the value.
we are like evaluating it to 22, right? But if you look at the even formula, it is directly giving us 11. It is actually giving the number, right?
No. See, for the even number, right? I took the two middlemost
Yeah.
observation. That is the fourth observation and the fifth observation. Here the fourth observation is 5 and the fifth observation is 6. So we need to find the averages of these two observations, of the two middlemost observations for even number of observations. Okay, it was 11.
Okay. Okay. No. My question was for odd observation, right? It is just giving the number, nth observation. It is not giving the actual value. We are based on the data, right? We are finding it out. Like we know based on the data, but let's say
Yes, we
the
don't need to calculate because it is already given. Like median is the middlemost observation. So if it is an odd number of observation, we can find the middlemost number directly.
So Pankaj, you can assume like this. You are supposed to find a value from your distribution above which half of your data lies and below which your other half lies. If you consider odd thing, suppose I am having 11 elements, then you can split it like this: 5 plus 1 plus 5. So that if you consider the sixth element, then 5 elements are below that, 5 elements are above that. Whereas if you consider a even set with 10 elements, why if I divide into two, there are 5 and 5. So to find the middle point, I will have to actually again find somewhere what is another additional point which will separate these into two. So for that, I will take again the margins of that first 5, the end one, and the second 5, the first one, and I will take again the mean of them. That is why this difference how we approach the even and odd thing comes. Basically, both are one and the same. We are trying to find a point to like equally divide my data so that everything above that and everything below that both will be like 50% of the data. With the whatever median value that we compute, that is exclusive of this half. So that is why this difference in like equation or this thing comes for odd and even. So basically, if you practically think both are one and the same, you are trying to find a value which will split your data into exactly two. I hope it is clear now.